started, let me use my big voice. Hey everybody. Alright, we're gonna get started here. Slowly. Well, first of all, thank you for coming here today. We have a very exciting event. This is the new topic, new buzzword, big data and analytics. So yeah, thank you for all coming and contributing in our group. By the way, the group founder, Shubrata Devda, owner of Analysis Express. I'm gonna just give you a quick rundown about the group, where we, what we have been doing, where we have been, and how we got here today. Um, so let me see. I have a PowerPoint presentation here. All right. All right. So the Cincinnati Business Intelligence Group, CBIG, is the new name. It's actually a LinkedIn group. We started in LinkedIn. We have 372 members currently, uh, primarily for business intelligence, business performance management, analytics, data mining professionals in the area, in the local area. Our company's members come from all of the major companies in the area, GE, E&T, Fifth Third, Kroger, Vantive, of course, and Lexington. Also, all of the prominent consulting companies, okay? And software vendors such as Oracle, IBM, BCC Systems, LexisNexis, for sponsoring our event today. Um, Member of this group. All right, so the group started, the first event was on June of 2010, so it's about roughly 2 years. Um, the group has been around. This is our 10th networking event so far. The first 5 was sponsored by our company, and then it has been sponsored by companies such as Indica, which has been bought by Oracle recently, Pinnacle. Anybody here from Pinnacle? Yes, thank you. Calvin Consulting. Anybody from Calvin? ICC. Sajati, I think I've seen. Yes, thank you. And Informatica, companies such as them. So thank you very much for sponsoring the event and helping this group come to this point. All right, so the group event size, the first few events were at a bar in just networking, purely networking, over some cool beer. Um, they started out to be a small group, about 6, 7, 10 people show up on events. Then last few events, we started seeing 30, 40 people show up. Today we have about 50 some. How many? We have about 55 RSVPs. Okay. So we have a great, over 65. We have a great turnout. So. All right, we have a Facebook page. All right, with all the pictures and all the survey questions and all of the interactions. So, if you have a moment, if you're a Facebook fan, just go there and just send that you like this too. All right, let me see. All right, the board members. So, Kelly Sloan, she's not here today, but I'd like to introduce you to Alejandro from Hillrom. Without his help, and Kelly's help, it would be possible. All right, so business proposal. Do you want to volunteer for the next event? There are a lot of activities, a lot of preparation that requires help. This group is not by just one company. It's for all companies to come together and foster ideas and networking. So it requires a lot of help. All right, so I want Erin Iazo. She's not here right now from Calvin Consulting. She helped us this time on sponsored, working with the sponsors and all of that. So, she's not here, but I wanted to make sure that her name is mentioned here. Is anyone here from Calvin in this group? Okay. Uh, but they have been very active first with it. They also sponsored the last event. Um, you can say that. Also, I want to, special thanks to Joel Dunahu. He invented for giving us the space. This is a great the place, and hopefully this would have the opportunity to do events in future also. So I would hand it over to you. All right. So with that, I wanted to do some special recognition. Is there anyone here attending this event for the first time? All right. All right. Okay, good. Well, I want to welcome you all. Please make sure that you go to LinkedIn. Find our group. It's called Cincinnati. Actually, in LinkedIn, it's called Cincinnati Regional Business Intelligence Networking Group. So we have been shortening the name slowly. So find that. We have 372 members. Please connect with us. Facebook page. Very easy to find and connect with us. Okay. For the first time, we have some students here from University of Cincinnati. I wanted to kind of recognize. Okay, great. Welcome to the group. Okay. All right. Okay, this is just the Facebook page, so that's all. So thank you. Welcome to the group, and great speakers. So with that, let me hand over to Mr. Joe.
Slide 10 switch.
Yes. All right. Thank you.
I work in finance, so I have no idea why that slide is that small, but look back. Thanks, Rada, and just wanted to take a few minutes and welcome you to Savannah. For those of you that haven't been out here, this is our relatively new facility. We moved in here last June, July. So we're technically a 40-year-old company. I believe that history has started about 40 years ago with a company called Midwest Financial, and then it evolved. Ultimately, probably the most common reference you hear is Fifth Third Processing Solutions. That was kind of our working, we were a business unit of Fifth Third Bank. And then in 2009, as shows here, we had a private equity firm called Advent come in and take on a majority share from Fifth Third Bank. Fifth Third Bank still had a significant share as well. So we've been operating that way up until recently, where you can see, actually towards the end of March, we went public as a company. So we had entered the New York Stock Exchange. We're in our ticker symbol ENTV. So that's kind of how we're operating now as a public company here in Cincinnati. So from a business model standpoint, it's really a two-part business model, but the underlying theme is we process payments, right? So we help facilitate payment either to merchants, between the merchant and the financial institution. If we happen to have a financial institution on the other side of the transaction, then we're sort of the end-to-end solution in that situation. We're not always the end-to-end solution, but generally we have a portfolio that is merchants, and we have a portfolio that is FIs or banks, but that includes credit unions and other entities like that. So we generally, our story to Wall Street and to the analysts has been that we process on a single platform, so it's very efficient for us to process payments across various partners that we have. So as you can see from a footprint standpoint, we've got roughly 400,000 merchant locations. That's down sort of to the store level. Roughly, we've got about really 200,000 relationships with merchants and roughly 1,300 financial institutions that we service. Just from a volume standpoint, we're the third-ranked U.S. merchant acquirer in terms of transactions processed, number one in terms of debit transactions, and then number one in terms of transaction growth in 2010 numbers. And then from a market share on FI, we've got about 9% of the market, and again, about roughly 1,300 FIs that process with us. So we feel we're pretty strong in the market. And then just on the merchant side, and what we point people to. These are some of our clients. And again, you probably recognize many of the names on here. Kroger's obviously a big partner of ours locally, as well as Macy's. But generally, we play with some of the more well-known brands in the area. So anyway, that's just a brief history about us. In terms of our relationship with BI and big data and this topic tonight, obviously we feel we sit on a gold mine, landmine of data. We recognize our data as a pretty strong asset for us, and we're as interested as anybody in ways to leverage that data, either in new products or just better intelligence within our business to help us compete better. So very interested in tonight's topic, and appreciate you guys coming out here. Hopefully we can host future events if this geography works out with people. But thanks for coming out. And with that, I'm going to turn it over to Mark. His name again, if I'm going to say it right, Mark Langenbaum.
Langenbaum, exactly.
Outstanding. His wife used to work for Fifth Third, so it's a
I used to work for Fifth Third.
Oh, you used to work?
Yeah.
We still like it.
Oh. I was actually involved in that, going through and splitting up the data center, moving all the servers to one side of the room, all the other servers to the other side. They were putting a fence in the middle. It was quite a project.
Why did it take so long?
Well, do you want the right answer? The right answer is because of the centralized storage, the sand. It took longer to move the sand because you buy a big sand frame, and then this project gets a little this part of the frame, this project gets a little bit, and then you start intermixing. It was unraveling all the sand storage to break the companies apart. That's what really took more time than anything else. So, not to bore everyone. So, my name is Mark Langenbaum. I work for Oracle. I'm an enterprise architect. Does anyone know what an enterprise architect does? Okay, so basically, I'm interested in the business value of all this technology we talk about. I don't care about the underlying technology. I want to know what's it going to do for the business, how it's going to help a business meet their strategic objectives and goals. And Oracle basically sells me to our top clients to help them make transformational changes to their business model and to their IT model. So tonight I'm going to talk about what I call the business value of big data. If you're here looking for a technology talk, that's going to be in the next room later on maybe, but I'm not going to be talking too much about the underlying technology because honestly it'll put you all to sleep. But what I want to talk about is dollars and cents. What is big data? Where does it come from? Why should we be interested in it? I'm going to spend most of the time in use cases, how companies, real companies, are using data today to improve their business, increase their revenue, decrease their costs, or maybe improve our lives in some cases. So anyway, to our agenda tonight, what is big data? What are some of the common big data technologies? Again, it's not going to be a data technology talk, but I am going to introduce some of the technologies so that when someone says Hadoop, they're talking about big data. We're going to spend most of our time doing use cases because that's really the value of big data is how do we extract the value from that data? Otherwise, there's no point in going through the effort. We're going to talk about some considerations for Hadoop in the enterprise. We're going to talk, I'm from Oracle, we got to just briefly mention some of our products in the space and what are the big data takeaways. So for instance, how did we get here? It's kind of interesting. It's really a confluence of improving technologies. The cost of networking went down. So as the cost of networking went down, we put more devices on the network. As we put more devices on the network, we started generating more data. Well, that's fine, but until we had cheap storage, what do we have done with that data other than throw it away? Now with cheap storage, we can afford to save that data somewhere, but without cheap processors, we've never had the processing power to go mine through that data to get any value out of it. So it's truly a convergence, a confluence of these technologies, improving capacities, reduce costs, that has allowed big data to happen. And then we add millions of data collection devices. How many has, let's see the collection of cell phones here. Anyone's got teenagers, you know that they're on these things constantly just texting. They don't talk to their friends. Their friend could be in the next chair to them. They'll sit there and text back and forth to them. All that data gets stored somewhere. It doesn't just fly through the air and is gone. It actually gets written to disk somewhere. So we got millions and millions of these portable data collection devices, and we're going to talk about some of the use cases that borderline on, I think, Big Brother, but that's where we're going. So big data is, most people think big data is, I've just got a lot of data, but it's really the 4 V's. It's volume, velocity, how fast the data comes at you, variety, what types of data, and the diversity of the data. If it was just all data, it was the same coming in, we could generate an easy way of processing it, but because it's a lot of different things, it's hard to manage. And value. Again, if there's no value in the data, there's no point in doing all this. So today, only about 5% of data on disk is what we call structured data. And those are the things that we put in our data warehouses that we can represent in rows and columns. Those are what we call relational databases. Content management. We've been doing content management since probably the 80s when we started with email. Email became more and more popular in the 80s, I'd say. Email, documents, web pages, tweets, posts. We created new content management systems to manage that type of data. But now we're into this multimedia content. We had to deal with text like tweets and Facebook stuff, images, audio, video, sensor streams, biometric data, in 3D information. And that is where all the growth is today, is in multimedia. And that's what really makes it difficult to use our current tools to manage the data. In 2009, the world had 0.8 zettabytes online. It goes mega, giga, tera, peta, then zettabyte. I had to go look that up. A zettabyte is 1 trillion gigabytes. So, we all have thumb drives that are about a gig of data on them. That would be 1 trillion thumb drives to store that amount of data. And it gets worse. They're predicting by 2020, and this is an old slide, and by old, it was last fall. It's dated. Well, since last fall when I put this together, they were predicting that it would grow by 44x. So that by 2020, we would have 35 zettabytes of storage or data online storage, not on tapes, but actual spinning disk drives. Now, I looked it up last night. Now they're predicting, same study, but updated, 50 zettabytes by 2020. So it's already increased by 10%, 15%. Where is that data? Now, I do a lot of work with JP Morgan Chase. I guess I didn't mention that. I live in Cincinnati and I work in New York. I spend a lot of time in the top 5 banks in the country and a lot of time with JP Morgan Chase. They have 150 petabytes online alone, and it's growing fast. Their Chase.com gets 3.5 billion logins per year. So think about the log data and click data that many logins can generate. There's 234 million websites. Facebook alone, 500 million users, 40 million photos are uploaded per day, 30 billion new pieces of content per month. The New York Stock Exchange, 1 terabyte of trading data per day. And then Web 2.0, we have 147 million bloggers, and that's growing. And it's actually, well, we might talk about that later. That's actually an interesting use case for big data, because if you can identify who the influential bloggers are, you can get value out of that. Because if you then follow that influential blogger and he says, sell Chrysler, everyone is going to go out and sell Chrysler stock. Twitter is 12 terabytes of data per day, and 145 character chunks? 145 byte chunks, and they do 12 terabytes per day, and it's mostly teenagers just, I'm going to the bathroom, I'm going to the mall, that kind of stuff. I love this slide. What happens in the internet in 60 seconds? We send 168 million emails in 60 seconds. We do 694,000 Google searches. We do 695,000 Facebook status updates. And there's a lot more information I want to know about people. LinkedIn, that's how most of us probably found out about this organization. There's 100 new LinkedIn accounts per minute, and what's the Twitter? There's 320 new Twitter accounts and 98,000 tweets per minute on the internet. And again, that's growing also. So and again, you do these things, it doesn't just go out into space and dissipate. It's sitting on a disk somewhere. And now, since we have the technology, we're storing that stuff for a long length of time. Anyone watch Gold Rush on the Discovery Channel? Okay. My wife hates it, I love it. I liken big data to with these guys from Oregon. They didn't have jobs. They all decided, hey, let's go to Alaska and mine for gold. And they had no clue what they were doing. So basically, you have to sift through hundreds and hundreds of tons of dirt to get one little gold nugget. That's what big data is like. You've got a lot of content, but the value of it is dispersed throughout it. And you have to have techniques and technologies to find that content, find that value. And I think the gold miners had it easier. They knew what they were looking for. They were looking for gold dust. They were looking for gold nuggets. We get into big data projects a lot of times. We don't know what we're looking for. It's we just have a lot of noise, and we're looking in all that random noise of data for things that are non-random. And those are what we call relationships or correlations. And once you can find those correlations, then you can figure out if it's of value. So a couple of the key technologies of what we call big data processing. First is a NoSQL database. A relational database, as I said, you organize things in rows and tables. And each row has some key that you do sorting on. That's how you go find that row again. That's great for structured data. Non-structured data, like a video or an email or something, is more difficult. So we have what's called NoSQL, and it's not NoSQL. It's not only SQL. Technologies and databases to manage it. And you basically store an email, or you store a whole video, or you store a recording, audio recording, as a whole with one value that you use to look it up and retrieve it again. So that's a NoSQL database. And the NoSQL databases are designed to be distributed across a lot of nodes in a compute cluster. And some of the NoSQL databases, Oracle among them, you can actually have it distributed across multiple geographies. So you can have this one big NoSQL database that spans North America, APAC, EMEA, Africa, all those. You can have one big NoSQL database spanning those. The second technology that makes the big data processing possible is called MapReduce. Now, these technologies aren't new. They're new to this problem. We've been doing parallel processing for 20 years or more, mostly in the engineering world, where we take a big problem and we divide it up into a lot of little small problems. We spread it across a lot of compute nodes. Each compute node solves their part of the problem and then returns it to a central location that assembles those things back together. That's what MapReduce. We used to call it gather, scatter. We scatter it, then we gather it. So that's basically what MapReduce. I can go into a lot of ugly detail about how this works. I'm not going to bore you. But basically, we take a big problem, we split it up in the map function, we solve a lot of little problems, we bring it back to the reduce function, bring the problem back together, and provide a result at the end. Now, some companies are doing this. Facebook has something like, well, get into this. I think it's 7,300 compute nodes on a cluster doing this. Now, what's the value for going through all that effort? Let's think about sorting a terabyte of data. As I said, the New York Stock Exchange generates a terabyte of data each and every trading day. Well, it takes a single server 2,500 minutes to sort a terabyte of data. Or you can put it on a Hadoop cluster with 3,800 nodes, and you can sort the same terabyte of data in 60 minutes. So if you're generating a terabyte of data every day, and it takes you more than a day to sort it, how are you going to handle that kind of data? You can't. And before, we never attempted it because we didn't have the technologies or techniques to do it. Just to mention some of the technologies, some of the words that if you hear people talking about it, you'll recognize we're talking about big data ones. NoSQL database, MapReduce. There's probably 20 or 30 MapReduce solutions. The most popular is called Hadoop. And trivia question, Hadoop is the name of the stuffed animal of the son of the man who started the Apache Hadoop project. And that's why when you go to the conferences, you see everyone with a shirt with an elephant on it. That's Hadoop. HDFS is a key enabling technology. It's based on the Andrew file system. I said this isn't new. Andrew file system has been around since the 80s, but it's a way of taking a file system, spreading it across a lot of distributed nodes, and having redundancy built into it so that when that one disk drive craps out, you haven't lost all your data. Some other buzzwords: Apache Hive, HBase, Open source R. Open source R is the language that you use to do the statistical analysis of this data. It's a little bit similar to SAS. Probably a lot of people here have used SAS before. Yes, no? Okay, SAS. PIG is an attempt by Apache to make MapReduce programming easier. Today in MapReduce, you have to write a program to do the map function, another program to do the reduce function, and it's generally written in Java or C++, although you can even use COBOL if you want, but I don't know why you would. It's difficult. You have to have specially trained people to do it. This PIG is an attempt by Apache to make it easier to let mere mortals actually manipulate this data. And Scoop is an enabling technology that allows you to move data between a Hadoop cluster and a relational database. So let's put all these pieces together and see what kind of problems we can solve, or what we call use cases. Everyone has seen this, whether you know what's going on in the background or not. How many people have noticed that when I go out to a website, I'm seeing ads for other things I've searched on recently, or a restaurant that's just down the street from me? So you wonder how they do that. Well, it's not by accident. They go through a lot of effort. So basically, every time you go to a website, you get cookies on your PC or your laptop or whatever browser you're using. And when you go to another website that's got this type of technology, one, they scrub through your cookies and see what things you've been looking at. And two, based on your IP address, they know roughly where you live in the world. And they will collect that data into their web logs and profiles, and a couple times a day, they'll run a batch job through their Hadoop cluster to basically summarize all this data and load it into an expert system up here. Next time you come in and you go to their website, they go and they say, first of all, they check the database, they find out, hey, you've been here before, let's check the expert system. You're interested in fishing and gourmet restaurants and what else? Some other unusual thing. And they'll go search through their database of advertising customers, and they'll pull up ads based on the type of things that you're looking for. Now, some sites are even going even further, not just ads, but they're producing content based on what things you're interested in. So if I go out to a website, I'll see one page, you go out to the website, you'll see a completely different page, and we're really on two different websites, same address, but it looks different, it's different content. So the value to a business of this is it's targeted advertising. Instead of just throwing out an ad on the radio or the newspaper or the TV and hoping that of the 100,000 people that are watching a particular TV program and people notice the commercial, you're targeting to people that have interest in your product. So then after they get 1,000 eyeballs on an ad, then they send out a bill to the advertiser. That's one use case of big data. The granddaddy of big data right now is Facebook. They're really mining through the data, and I'll explain why. This is what a 4800 core, 5.5 petabyte Hadoop cluster looks like. It's I think it's 70 racks of servers. I won't get into the cooling and space problems, but anyone who's worked in a data center makes a picture will make you shudder. They're doing they're compressing, taking in 4 terabytes of compressed data per day, and it's personal data about people, right? Facebook knows everything about you. They know everything about your kids. They know your kids' birthdays. They know whether they're in a relationship. They probably know as much about your kids as you do, or maybe more, because your kids won't be honest to you, but they'll be honest to Facebook for some reason. They have 135 terabytes of compressed data that they scan per day through the Hadoop cluster. That's 7,500 plus Hive jobs per day, per day, and it's 80,000 compute hours of compute time per day. So they're doing daily and weekly aggregations of impression click counts. They want to know how to improve their website to get more use of it and get more users to sign up. So that's a big part of what they're using the Hadoop clusters to improve themselves. Ad optimization, they have ads just like every other website, and they're trying to optimize their ads to improve their ad revenue. User engagement is a function of user attributes, and that's why I'm saying Facebook knows everything about you if you have a Facebook account, and they can do all kinds of statistics that says, people in the age range of 30 to 40 are interested in these topics. People who drive this type of car are interested in these other topics. They can do, and they are doing, a lot of consumer research on that data. And what they call MicroStrategy dashboards. Basically, when they make a change, they want to track to see whether or not the change increases the number of people using Facebook or decreases the number of Facebook. And it's not just the users, it's how many times you've interacted with it a day. So they can tell within a week or so, once they make a change, whether that was a good change or a bad change. Now, I spend a lot of my time at banks. I've got a lot of banking use cases. First of all, one of the banks I work with, huge bank. So several people here, Fifth Third, I work for Fifth Third. One line of business at this bank is bigger than all of Fifth Third. And before they split off Bantam, I really wasn't prepared for the increase in size. Because Fifth Third was considered the 10th largest bank in the country. So you figure that the difference between the 10th largest bank and the 5th largest bank can't be, it's 5, right? No, it's huge. So 5 to 7 lines of business, what they've done, instead of letting each of their lines of business run off and build Hadoop clusters, they've built one big, ginormous Hadoop cluster, and they're basically selling it off as a service. So any of their LOBs wants to do any type of experimentation, and that's a good word, experimentation, with big data, they rent time on this Hadoop cluster. So the other thing they're doing is they're building a data scientist team. Big data requires some very specific educational skills. So you need people who can do Java and or C++ programming. You need statisticians, because really when you're trying to do correlations, it's all statistics. And I'll think of the wide world of BI tools. That's actually another presentation I do. If there's really one thing I can hope you take home with you is, if you go and your company is working in big data, you don't want to set up a whole big data infrastructure that's separate from all your other BI analytics. Think about big data as just adding a new data source to your existing BI analytics. You've already spent millions of dollars on your existing analytics infrastructure. You're not going to throw that away. These big banks are going to throw it away. So we have to come up with a way of merging the two. And I have presentations that talk about architecture, the architectural view of merging big data and traditional data analytics. Look at it as a new data source that you can apply your analytics to make better business decisions. Instead of today with relational databases, all of our data is internal looking, internal focus. It's our customer records, our inventories. If you add big data to it, you can add external data to improve your business decisions. So they're building a team. They've got 50 data scientists so far, and they're hiring more. At the last Hadoop cluster in New York, they were actively recruiting new data scientists to this team. And they're trying to actively influence the evolution of big data tools. So here's some of their use cases. One is ETL. They've got a lot of problems that they want to do reporting or analytics on, but the source data is just too great. And when they try to load it into a relational database or the traditional analytics tools, one, it's hard to load that much data, and two, trying to do full table scans of large amounts of data is just impossible. So what they do is they use their Hadoop cluster to map, reduce, and filter that data into a smaller subset of data that they actually need to operate on. So then they load that into the relational databases and do their traditional analytics and reporting on it. They estimate, this is Basel III liquidity analysis. Everyone's familiar, We've got some new controls on banks. Basel III is liquidity analysis that they have to basically report to the government. Right now it's monthly, and it's a huge calculation that they have to do. They're doing it monthly. It's probably going to get weekly here soon. And they've reduced their processing time by 74% by doing this pre-processing, filtering through the data, loading a smaller amount of data. The other thing that's kind of interesting, anyone from EMC here? Anyone? Okay, so Hadoop cluster. What they're using the Hadoop cluster for is they got a lot of data, but they don't know if there's any value to it. But they think that sometime, someday, somewhere, to somebody, that data is going to have some kind of value. So they want to save it. You can't save it to tape because it's just too hard to manipulate tape and get the data off of it once you need it. So they're using their Hadoop cluster to basically save all the data that they have. So a Hadoop cluster, just to go back to the technology, picture a single server, let's say 2 CPUs and 12 disk drives. That's a compute node. And then put 7,000 of those together in multiple racks and multiply how many petabytes of data that you could store. And the HDFS file system, for redundancy, stores 3 copies. So they figured that they can store 3 copies of all their data in their Hadoop cluster and still save $100 million over 3 years versus, say, putting it onto an HMC storage frame. Because you're going from high-priced SAN storage to commodity drives that you can get a terabyte for $65, right? So that's why I didn't want to slam EMC if people was in the room. Recorded futures. This is an interesting use case. Web pages and news articles and just things that we tweet and put on Facebook have predictive indicators on it. I'm going to do something next week. I'm going to do something next month. I'm going to do something on this date certain, or something is going to happen on. I might not do it, but someone else I know is going to do it. Or some company's going to, Facebook's going to IPO on, does everyone know the date? May 18th, I think. Is that right? Oh, okay. So Facebook is going to go into an IPO this month. They're mining through all sources of web data they can get their hands on. And they're looking for these predictive terms. And then they're putting it into a 3-dimensional relationship that has the metrics. It's, what's going to happen, when is it going to happen, and what are the impact on that. And they don't care if just one person's doing it, but when they find out that a lot of people are going to go out and buy a car this month, or a lot of people are going to in the market for buying a house, or when you can group that data and you find that there's a herd of people doing something, that has value. And they sell that. They mine through all the data, and then they sell a service to their customers. They have a website that you can go to, a web interface that you can go and look through all the data that's been filtered and compressed. Or they have an API so that you can write your own programs and over the internet basically interface with their huge databases. So you can use that. They're using that to predict trading volumes on the stock market. They're predicting stock returns based on sentiment analysis. They're predicting volatility in the stock market based on future events. So they're able to, I'm hearing, at least their presentations, because I've sat through some of their presentations, they've been able to correlate to a pretty high degree when we're going to go through a series of fluctuations on the stock market. They know that a month ahead of time. And this is what I talk about, single blog impact analysis. They go out and that 140 some odd million bloggers that are out there, they know who the influential ones are. They can tell you who to follow depending on what industry or what your interests are. And you can use those bloggers to try to predict the direction of certain events, whether a product could be successful, or it could be a movie. Maybe it's a movie reviewer, some guy who goes out to a lot of movies and he blogs about them. Him canning a movie could have a complete effect on the box office. So now, if you're a movie studio, you want to find out who those people are, and you want to wine and dine them. You want to treat them well so that they'll give you a favorable impression. So this is shopping cart conversions. Any company doing any type of online marketing or selling, like Amazon.com or Walmart does a lot of selling. We've all been to their stores, but they actually do a lot of selling online too. They have the problem where people will go and fill up their shopping cart, they go to the checkout lane, and then they walk away. And they just got a big shopping cart full of merchandise that could turn into cash, and it doesn't get turned into cash. So they do a lot of sentiment analysis of big data. They go through their click logs. They want to understand what types of things, try to understand the mentality or, what gets the customer to complete that transaction. The other thing they do, you notice that when you're shopping on Amazon, if you're looking at a certain book, they'll say that most people who bought this book also bought these other 5 books. Or if you bought something that requires batteries will remind you to try to sell you batteries before you check out. Well, that's what they're doing here. They're increasing their revenue by basically understanding the shopper's mentality. What they're looking for and what makes them buy. And I've been through some Amazon's presentations. They claim that within 5 clicks, with a high degree of certainty, they know whether or not you're going to buy or not. You might spend an hour going through their shopping cart or their site, but they know within 5 clicks whether or not you're a buyer. But they wouldn't tell us how they know that. Let's see. Here's another good one, fraud analysis. This is back to where I was getting to with you don't want to have big data here and traditional data, BI analytics over here. Fraud alert and analysis. What you're trying to do here, let's see if I got a better picture. So either you're a bank, you're a credit card processor. A bank would be like anti-money laundering, looking for people who are laundering money, or credit card theft, where people have somehow stolen your credit card information and they're buying things. If anyone ever had their credit card declined, you had to call a credit card company and they said, well, we noticed that your shopping patterns are weird today. I got it because they claimed I couldn't drive from one gas station in Florida to a gas station in Georgia in the length of time that I did. And when I tried to use my credit card at the second pump, they declined it, and I had to call and find out why. And based on their analytics, they said I couldn't drive that far in that length of time. But I did. So that's an example. That's an example where you want to combine the 2 types of data. You've got streaming data, things are happening now. You're running it through your Hadoop cluster. You're feeding it through a complex event processor. Event-driven analytics, and you gotta match it with your historic profiles, your customer data, their blacklists, if it's anti-money laundering, or you may know that some areas have problems, so that your blacklist. You have to go combine that real-time data coming in with historical data that's in a relational database to come up with your alerts. So if you can't combine the 2 worlds, you can't do this type of fraud analysis. And this is literally today saving banks. The figure I saw was $140 million per year. They're catching that much additional fraud by using these techniques. This one scares me. It goes back to my other example about I can't drive from 2 gas stations, between 2 gas stations. There are car companies that you can get a discount. Well, initially you'll get a discount rate. If they do this to me, eventually I'll be paying more. They'll put a device on your car, and it will monitor whether or not you come to a full stop at stop signs. Well, first of all, it has a GPS in it, so it knows everywhere you are. So it knows the speed limit of the road you're on. It knows where the stop signs and stoplights are. So it monitors whether or not you come to a full stop, whether you brake hard or you accelerate hard, how much you drive, because they want to base your insurance rates. The theory is if you're on the roads more, you are more likely to be in an accident. Where do you drive, urban or out in the country, and whether or not you have accidents and things. That's a tremendous amount of data that they have to somehow upload from your car occasionally and process through it. Now, again, just that data in a vacuum is not a lot of use to it because they have to pair those driving habits up with a particular customer and other things about that customer. For instance, we all know that as we get older, our insurance rates go down. When I was 16, my insurance rates were horrible. So they combine the streaming data, the sensor data, they run it through their Hadoop cluster, they condense it into basically a driving profile, and then because they have to be able to defend this in court, if there's ever any type of litigation based on, well, you're charging this group of people too much, they have to go through their historical data to show that there's a correlation with people with this type of driving profile match up with this profile of a group that has this percentage accidents per year. It's really interesting because I call it a fingerprint. They basically condense all your driving data down into something, a pattern. You can't go and look at this thing and actually read anything into it. It's just basically a pattern, and they do pattern matching. It's kind of like how many people have LinkedIn accounts? They take all the data that you put into LinkedIn and they mash it through an algorithm and they come up with a pattern. And then all the people who put up job postings, I'm looking for a person with these qualifications, they mash that through the same algorithm and then they do pattern matching, kind of like trying to match fingerprints. And any place that they match a pattern, they'll kick out your resume to the person advertising for that position. So they're not just doing word matching. They're actually, it's like fingerprints, I think. That's how I compare it. Other areas of value, healthcare. We're estimating that, by we, it's the whole industry, not Oracle, not me. But using techniques of big data, there's going to be a $300 billion per year savings. And one example is CT scans. A lot of times when you get a CT scan, they also do a sonogram as just automatic. If you're getting a CT scan, you're going to get a sonogram. And they found out that by analyzing the data, they can identify which patients benefit. Oh, I'm sorry, I'm running out of time. Okay, real quick, 300 billion in healthcare, 60% increase in margin for retail, billions of dollars in banking from fraud detection, location-based services, that's GPS stuff. They think there's a $100 billion a year market, and utilities will reduce their costs 22% by the year 2030. And I've got a whole presentation just on use cases. If you can look real quick, here's some interesting use cases that we don't have time to go into. And this is my bridge of chasm slide. I'm going to just go through real quick. So here's the way Oracle looks at the whole data world. We have big data appliance here. We have traditional database in our Exadata database server, and we have Exalytics over here. We have software that joins all those worlds together. We call those the Oracle Data Integrator, or we also call them the Duke connectors. We can basically combine the two worlds and use our traditional analytics tools to do these types of processing. And it makes it integrated. We use InfiniBand, which is high-speed, low-latency networking, 40 gigabytes per second. And we can load big data at 12 terabytes an hour into a relational database with our Hadoop connectors. So we have the view that you have to expand your world, your data world, with big data. It's not either or. It's not two separate worlds. And just, why do you want to do it? There's a lot of opportunity. Your competition might be doing it against you. So there's the threat and the opportunity. And basically, you want to increase your revenue, reduce your costs. Those are the two big goals of big data. Any questions? Nope. So I've explained everything about big data. You don't have any questions? I'm good. I didn't see too many people nodding off, so at least I kept it interesting. Okay.
Thank you, Mark, for your presentation. It was very interesting, and at some time it was a little bit scary, wasn't it?
Yeah, I am. That insurance thing, they're going to get me.
So, while we switch over to our next presenter, we're going to hand out some forms. We are looking for either structured data or unstructured data. So don't worry about it. We're going to give the data to Mark, and he's going to analyze it for us. and I was thinking when he was talking about terabytes and zettabytes. You know what comes up after a zettabyte?
Terabytes, petabyte, exabyte, zettabyte.
Zettabyte. So what's next?
The extras back there.
My daughter's closet. A lot. It's just a big wave of information. So I think we should have done this before, but Mark Langenband, he has more than 30 years of IT experience, and he has been in different positions with Microsystems, CBIG, and Oracle, and IBM, and we really appreciate your time and all the information that you gave to us, Mark. And so we are going to switch gears, and we're going to have now Dr. Holt. Dr. John Holt, he works with HPCC Systems or LexisNexis, however we know it, and he has over 30 years of he has been with LexisNexis for over 30 years, and he has been working on multiple projects, including some insurance application systems to help assess risk and detect fraud. A big niche for some people, right? So he is going to have a presentation that is obviously going to be very interesting. He's going to present solving big data problems with open source HPC systems platform. So with that,
Usually only takes a few seconds. While I'm doing this, my colleague, David Hoff, has a questionnaire or a form or something that he would like to get from you guys, which you guys to figure out, and I may actually even need to get his PC base to do this. And the reason that we're giving you this is it's a shameless attempt to bribe you with a Kindle. Because the questionnaire acts as your entry into the drawing. So, blank ones, of course, can't.
I am that colleague, and I don't want to detract from you providing feedback to Oracle, but when you are done, if you would like to register to win the Kindle, our registration form looks surprisingly like the questionnaire.
Yeah.
And I have pens to hand out if you don't have a pen currently, and I'd be thrilled to hand this to you.
They all have that.
No, it's a mini. What is HPC Systems? LexisNexis has been in the big data space for a long time. We built a platform that we could go from the collection of the data all the way through the delivery. And that it's not just the ETL work, but that's also doing the linking, doing the aggregation and the linking necessary to put stuff together. So it's our platform has what we think of as three basic things. It's a grid, it's a big cluster of hardware. It's a data-centric language that you use to describe the solution to your problem, not the imperative steps to solve it, which does create some problems with people who have only done work with imperative style languages. It sometimes can be the transition to a declarative style language or functional language can be a difficult step. And it is an integrated delivery system. It's integrated all the way from the collection work all the way to the delivery via high throughput, low latency transaction processing, query transaction processing. So basically, the language, of course, is suited to data, so your solutions in this tend to be described fairly compactly and fairly eloquently. It does have some equivalence to SQL. SQL is a data manipulation language of a sort, and as are we. So you can select and persons, in this case, is an attribute that describes a file. You can filter this file. Field name is a field, obviously, or first name is a field, obviously, so this is the subset of the data that has the first name of Jim. The equivalent SQL statement. Far side, count, dedupe, aggregation functions such as sum and average, min, max. Cross-tabulation functions, and the one that actually really makes the system, well, sort, pretty important as well, but join is really where the heavy lifting is a distributed join in a shared method compute environment. So our basic structure, you have record layouts, record definitions, you have transformation functions that say join we call to do something, or in this case what a rollup might do or a project might do. And there are lots of functions that are written. And then you are, as we write attributes, you are essentially writing a function, some of which can take no arguments or take arguments. Our open source offering has a machine learning module or a set of modules for supervised learning, unsupervised learning, which is basically clustering type things. So you can do classification, linear regression, a variety of association minors, and clustering engines. And this is all in the open source problem. And of course, you obviously need statistics. The simple ones, of course, are the univariate stats, but the correlations are useful, Spearman's and Pearson's and Kevin. We can do a lot of parsing. We parse text that has very little to it, so you can do entity recognition, entity extraction type things. Look for word sequences, phrases, whatever you want to do. The machine learning has tools in it so that you can do collocation analysis, so you can look at interesting bigrams, interesting trigrams of words, so you can detect, say, idiomatic expressions or terms of art in different languages. For those of you who have been doing a lot of work in Hadoop and like to use a builder tool to do your building, you probably are using Kettle, perhaps with Spoon. Spoon is kind of a graphical tool for Kettle. We have developed a series of little Spoon Kettle drop-ins so that if you have a Spoon canvas, you can drag and drop these little things to do spray and despray and data set and all of that. Here's an example of a workflow that's done in Spoon. Unlike the typical Kettle thing, when I drop one of these little widgets on my canvas, I can usually get work to happen in my Hadoop cluster. What we do, we have execute places. In this particular one, there's an execute at the very end of that chain. So you can, so that's a little bit different in our world than you'll see in Hadoop. We also support JDBC, so if you like to use that, you can build a client that's using JDBC, and connectors for standard SQL things. You're certainly not going to be able to create tables, but you can do you can read tables, and if somebody's done a materialized view for you, you can do that. You can do filters, aggregations, joins, taking advantage of these. That, of course, helps us offer a tie-in with BERT, which is an Eclipse thing, so that you can use BERT if you're trying to do one of those little management displays where you have little interesting icons with neat stuff in them, scorecards or whatever the terminology. I don't do a lot of UI stuff, so I don't follow that. And so core benefits that we have here, we believe a major core benefit is just the better analytics that you get because of the speed and capacity. But we're a single data store. As Mark mentioned in his presentation, a lot of people are using commodity clusters with disks to do data store instead of putting it on a NAS. That's really what this system does as well. That's what makes it work, and of course, it keeps track of all the files. We don't do 3 as in Andrew, we do 2, but they automatically recreate the replicant if one of the replicants dies. Little short thing on Hadoop versus HPCC. We have 2 main pieces. One is the building tool, or the data refinery tool that we call Thor, and it really is a big hammer that you can use just to pound the widths out of your data. And the other one is a data delivery engine that we call Roxy. I can't really explain why it's called Roxy.
Wait, I've got that one, John. It's Rapid Online XML Integrated Engine or something.
Yeah. That's usually a revision.
Information exchange. Okay.
Yeah.
Rapid Online
XML information exchange. Yeah, I'm suspecting that that's somewhat revisions, but that is the official part of mine. So, and here we see our technical landing zone with big data, and then you can have users out there giving reports. Now, the Hadoop stack is much, much more complicated. If you're an operations person, you have a lot of moving parts. If you're a programmer, you still have a lot of moving parts. For data delivery, you have Cassandra and HBase and Zookeeper. ETL, you may have Hive and Karmasphere and some other things. You also have databases like MySQL and Oracle and Postgres. That's a name in the past. And you have a bunch of different ways that you can go about doing things. MapReduce or BIG are very popular. Cloudera did a test, and I really don't like using this slide because it wasn't a TerraSort. Cloudera didn't do a TerraSort. We took the data that Cloudera did when they did this little test and proclaimed a 130 seconds to sort this data. They did take 40 nodes. We took 4. So that's pretty impressive. We basically did the same thing they did, and so much more than that. Another set of slides to talk about the data refinery. What I really want to get to is kind of the next one. This is some examples of DCL. It's a declarative language that said it is implicitly parallel. Note that you, the developer, have not written anything describing where your data is or how it's distributed. This particular join operation is going to take these 2 data sets and to the extent that it needs to, this is the hard equivalent or hard equal on the join, it's going to make certain that all the records with the same line number are on the same node on both data sets. And it's going to do that. It's going to take this left data set as its template for its initial shot at how the data is distributed, and then it's going to redistribute the right to match the left, and it may move the left a little bit if necessary to get somewhat more even. Sort is also one of those functions that will cause your data to be redistributed. So this all works without you, the programmer, really knowing anything. Now, obviously, if you know where stuff is, the language will allow you to take advantage of that fact. So you can tell a join, I want you to do it locally because I've already made certain that all the right records are on all the right nodes. Right? But if you don't, this will do it for you. Right? Which is fairly nice. It's implicitly parallel. So you don't worry about doing any synchronization points or anything like that. If you've ever programmed in MPI, for example, right? I have a big payload cluster and I want to do something. I'm going to have to decide where my synchronization barriers are going to be in my process. I'm going to make that happen by coding it just that way. In MapReduce, I'm essentially doing my MapReduce. I'm doing that as a series of MapReduce stages, right? And each one of those stages is a synchronization barrier. I'm figuring that out as the programmer and understanding how that all works. In this particular language, you don't need to do that. But because the language is declarative and not imperative, because it is a description of what the end solution looks like and not the steps to get there, the compiler takes your description and recognizes that it is a tree, right? It may be not a classic tree, it may be a directed acyclic graph, but it is something that it can figure out all the paths, do the optimization, and do the parallelization for you. So you don't do it. Your code looks the same whether you're running on 1 node, 10 node, 1,000 nodes. Right? It just doesn't matter, and it runs. So to us, that's a big deal. The data delivery engine, low latency, is a big deal. It is redundant. It's a shared nothing cluster. Every node can accept the transactions. All the nodes that are necessary to participate in the transactions participate in them because the data is distributed amongst those nodes. So if I'm a node, I get the transaction, the underlying machinery says, oh, well, the data to resolve this is in these 4 nodes. I'll send the broadcast message down those 4 channels, and answers will come back. Right? The kinds of operations that are done on the indices on the individual nodes are things like filtering, aggregation, things like if you could say group a set of records with a grouping criteria and say, I only want to see the records where somebody had five automobiles in the last 10 years. I could have that construct, express that, use that in an aggregation test, and only the records that satisfy that aggregation criteria would flow back up from the nodes holding the data up to the flexible data model. Hadoop, you're going to essentially do tunneling. You're going to bury your data. I don't know if too many of you are doing it. It's key value pair or some key value pairs. Anything can be described in that value, but you're going to write the code. Somebody is going to write the code so that that class can flatten itself out onto a string, and on the other end, fluff itself back up, right? So that has to be done, and now you're going to have to worry about version control, versioning of the string encoding technique and such. Our world, you're not flattening out anything, you're not encoding anything, you're simply describing the data as the fields. You're describing the full data. The fact that you're only using 3 fields tells the compiler that the rest of the fields on this record they have to come up off of the disk, but they don't have to go much further than that because they're not used, right? So all that data gets paired away in a project. So only the data that you are actually using is moved through the machine. Processing model is, you can do MapReduce in this. If you really like MapReduce and your problem is a MapReduce problem, then MapReduce is great. I've done a lot of MapReduce stuff. Works well. But MapReduce is not the only way to cast problems, not the only way to solve a problem. It's not even the best way to solve many problems. This gives you a lot more flexibility because you can do your joins in a much more natural way for your problem. A lot of people don't like ECL because it is, at one point it was a proprietary language, and I suppose to some extent it is still kind of proprietary, but the platform and the language and all of that is open source. So it's not an ANSI standard. So I don't know. Is it really proprietary if it's open source? I guess. Last thing is, for people who do a lot of BI, I have all my data on a set of these clusters. The infrastructure knows where all of the data is. Other people have written attributes to do interesting things on this data. You simply use functional composition to leverage the other people's work, right? It's somewhat similar to using a class library, but it's a whole lot easier than using class libraries if you're an object-oriented type guy. Functional composition is a very powerful and very kind of programmer friendly, as long as you're willing to let somebody else drive. If you have to drive, then you're going to hate it, right? If you can't use other people's work the way they've written it, then you're going to hate it. But if you can let other people drive on occasion and leverage their work, then this is a great system. So you can use their work, you can set up the problem, you can run the problem, and you can get some really massive stuff. A friend of mine, it just as kind of it's a little bit more than a lark, but it's kind of an experiment, wanted to know if he looked at who was holding the leases of vehicles that were in accidents, was there any interesting relationships, right? And he found that there were a set of leaseholders that had people leasing their vehicles that had a huge number of accidents, right? It was a fraud ring. It was a fraud ring in Minnesota. Those kinds of things are the types of things that data scientists or somebody who wants to play with the data can do in a system like this. And it's easy to add capacity. They're just commodity nodes. Yeah, there's heating, power, and light, and that's getting pretty expensive, but it's pretty straightforward. And as a data practitioner, of course, I'm always excited about that aspect. So that's kind of it. The system is it is open source. You can go to hpcsystems.com. You can download it. It's on a VM. You can download documentation. You can get to the source. You can build the system yourself, or you can just put it in a. It has comes with virtual machines, and you just write it. Works pretty well. Any questions? No, I went through that pretty fast.
So what's the biggest difference between Hadoop and HPCC? Why would you pick one over the other?
Well, pick one or the other. I'm kind of ready on that. But
This is better.
yeah, I have built very large-scale Java distributed compute things in Java, right? So I know how that world works. My biggest thing, the thing that I like the most about this is the kinds of bugs. I write code, I'm a developer, right? So the kinds of bugs that I create and have to find and fix, or my peers create and I have to find and fix, that class of bugs is entirely different than what you experience in Java. Right? In Java or in C++, first, you have things. Well, the classic problem in Java is I have an object, I put it in a collection, and then I do something really stupid with it because I've got a reference. I change a key. Now I can't find it in my collection anymore, right? I mean, and tracking that down, finding that, figuring that out. Right? Or you're using, because you know that your class is supposed to be, or these ways to use the class are thread safe. So you have something that's not thread safe because you know no other threads are going to get to it, right? Yeah, right. When somebody else is using your class, then you have no idea. Okay? So those are the reasons that I like to go to a much higher level. I like to experience a whole new class of errors, things like where you really can't use you've got you've got one name that is using a different character encoding in what you have French translates of Arabic names, and you have English translates of the Arabic names, and you're wondering why you can't fuse these two data sources. Well, it's because they're using all different characters to express the same name. Right? That's the kind of errors that those are more interesting errors. So that's kind of fun.
What's an example of a place using HPCC system? What's a big data example?
One of them is when you go out and shop for insurance, right? I love it. If you guys go out and shop for insurance tonight, right? Go on the website, do Geico, do all of them, because when you go shop for insurance, the insurance companies need to look up your accident history and things of that nature. Well, that's powered by HPC systems. It's an example of big data where we mine all these things, and we managed to keep you associated even though you've moved between 7 states and 13 cities in the last 10 years. Why so tracking it. Yes?
Techie, but is ECL interpreted or compiled?
ECL is compiled. The compiler generates, I love to talk about these kinds of things. The compiler generates C++ code.
Okay.
We use GCC, so compilation units contain not only the platform classes, but also the classes that are generated in your code. So because the compilation units are huge, right? The optimizing stages in GCC can actually optimize out lots and lots of calls, right? So your C++ code runs really fast, right? Not like, I mean, if you're writing maintainable C++ code, you're going to maybe have an interface abstract class, and you're going to have a couple implementation classes. The client's only going to see the header, right? The compilation unit is only going to have the header, and you're going to not get any of that optimization that the compiler have. In our case, the compile unit is everything, right? So the compiler can see it, the compiler can optimize those pathways out.
Is the syntax, is it an extension of prefix like Lisp, or is it?
No, it's, you notice it's a little Pascal-y, like, you know, you have colon equal, definition. It's a couple of the guys that came up with the language were Borland Pascal programmers. Right? Okay, so there's that. And some of the guys worked on Clarion, which is a 4th generation system that had its heyday back in the 80s. I think if you're as old as I am, you may know that. So, and that's kind of where it is. So, and it is organic, right? This language is organic. If the language has some features in it that I really wish would go away, but you know. So it's organic. It's grown. It wasn't designed. It wasn't something once. It's fine. Pieces.
So you're talking about data model, right? So how do you come up with a data model for unstructured data?
Well, usually I have interesting questions that I want to ask my unstructured data. Okay, so really what I want to do is I want to take, and the other thing, before I go, first, there's very little data in the real world that is truly unstructured. There's always some little bits. There's usually metadata that's attached to it. If nothing else, it's origin information, time information, right? But what I want to do is I want to extract interesting features from this blob of goo. I want to turn it into structured data, right? So that's what I'm going to do, and I do that as a series of cleaning operations. So I want to build a data model. If I have a bunch of data, I want to create a data model to answer the questions that I want to ask this data. That's how I do it. Other artists may use different.
John, can you just add to that the ways in which the unstructured data can be distributed across the cluster?
Oh yeah, well, let's say you have a bunch of unstructured data, right? So you bring it into the cluster, you're going to spray it, and it tends to distribute across the nodes. I can do it in chunks. I can do it by some natural boundaries. Maybe the unstructured data is a set of small files to begin with, or have a file-like structure, right? So I can, but I'll spread it amongst the nodes, and then I can interrogate it and parse it. Parse is one of, for textual data anyway, parse is one of my favorite commands. Now, this system, I do not do a lot of analysis of images on this system, nor would I. It's really, it's not kind of, I think I would want to do a different system if I were to do a lot of images.
You can store image files on it, and you can interrogate the image, right? But
Yeah.
not image processing that you want a GPU system based on.
Yeah, because I could think of pattern matching inside photographs. and stuff
Correct.
like that.
Yeah.
To match all of the image, all the image files.
Right, it would be just really painful, right? Do a classic edge detection thing, right? Now, if you had a bunch of nodes that had really cool GPUs,
Right.
you could use the system, but I mean, then you'd be using ECL and the system more as a data flow management system, not really down in data analysis. Yeah. So, yeah. Now that's an area where I might fall into using Hadoop, perhaps. I don't know. I'd at least consider it for more than 2 minutes. Any other?
So, is there an application for machine learning as well? And can you give a real use case where you use machine learning in the
Given my knowledge of our machine learning implementation and the algorithms that we selected for it, right, I would say no. I would say that I would not want to try to build a unsupervised classifier to find edges in a tip, right? No, I would not want to do that.
I think you maybe ask in general, not
Just
for
in
image
general.
processing stuff. Exactly.
In general, if I'm doing unsupervised learn, if what I want to do is classify documents, right? And so I have a bunch of example documents that have positive and negative examples for each classification. Yeah, I use our classifier for that. Use the ML classifier. Yes. That's exactly the kind of thing that it was built, but not in. Any other? All right, so now we need somebody to draw the names.
If you haven't passed down the HPCC feedback form and you would like to enter the drawing for the Kindle, please do so. Thank you.
This is an unabashed drawing.
We are shameless, I admit it. That's why I'm doing it, not Dr. John Holt.
No, you're not allowed. You're from now on. Absolutely not.
Here, I can't be biased, so I actually need you to hold me for John. And Dr. John.
Yeah, we need an unbiased person. Certainly not one of us.
You're unbiased, you absolutely are unbiased. Oh, we have one more, sorry. Yes, sir?
I'm closest to the door.
I went to our marketing department and I said, Kindle me this morning to pick that up before I left. And 3 other people in the department looked at me and said, is that all it takes to get one? All right, so rifle through there, please. I'm not looking.
And the winner is, come back, Raj.
Here you are, so thanks, John. Thank you for your feedback, thank you for allowing us to broaden the opportunity. I would like to.
Oh, yes. Sure, yes, we need a picture of the, and, you got all 3 of them? Or
No, it's not all. All right, one more.
And you will, office.
You guys ready?
It's gonna be in Facebook in 2 seconds. Thank you.
All right. Well, a couple of comments before we wrap this up. First of all, thank you to Mark and John for the presentations, and also thank you to Banfield for hosting us, and LexisNexis for being our sponsors. And we really appreciate you guys taking the time to be here in this meeting. And we also love to see your faces. And the first rule about this group is you do talk about this group. Right? You people, please spread the word. We want this group to really grow up. This is about IT professionals in Cincinnati, business intelligence people, getting to know each other, hanging out, networking, and who knows, maybe from here, new companies are going to get created in Cincinnati. Why not? But sometimes we bump into each other and we don't even know that we are two people set aside that we are from the same discipline like BI. So we really encourage to get connected, no matter what level of professional, how many years of professional that you have in your portfolio. Please connect with us on LinkedIn, look us up in Facebook, and we are, as usual, inviting everyone who wants to be in our committee or board to get involved for our next event. We have a couple of sponsors lined up, but any sponsor that wants to host this kind of events, you are more than welcome. So
with that, unofficial after hours is going to be at Bar 71 next door, 885, or it's just literally next door. So it's for networking, get together and a couple of drinks. So just want to make it.
Again, thank you for coming, and we have still some food if you want to grab some food. So help yourself, and we hope to see you in our next event. Thanks again.
Lunch or coffee sometime?